हम H1 और H2 को कंबाइन करेंगे और उनका जो कॉम्बिनेशन होगा उस कॉम्बिनेशन के ऊपर अगेन SHA-256 हैशिंग टेक्निक अप्लाई की जाएगी और उससे हमें H12 मिलेगा। और उसके बाद ये जो H3 और H4 है अगेन इन दोनों को कंबाइन किया जाएगा और
right, part 2, how mining works. Let's have a look. So we left off last time over here where we have this block, and we now know that we can control, or we can vary the hash of the block by varying the nonce, the number, the extra field that we identified. Okay, so how does this tie in with mining? Well, let's have a look. The first thing that we're going to need to do is to make Hello and welcome back to the course on blockchain. And today we're going to be talking about mining. This is going to be a two-part tutorial. All right, so let's have a look where we are on our map. We've talked about hash cryptography, the immutable ledger. We've now also checked off distributed peer-to-peer networks. And finally, we're moving on to the mining. In these two tutorials, we're going to find out exactly what the whole system is about. Why is there mining? What's the competition that everybody's participating in? Why are so many resources allocated or dedicated to mining blockchain and bitcoins and things like that? So let's have a look. Here is our block in a blockchain, and as we discussed, it's got a couple of fields. So it's got the block number at the top, it's got some data, and as you can see here, I've put in some fake data where I sent Adlan 500 adcoins, then I bought something on eBay for 100 adcoins. Adlan sent some person named Joe 70 adcoins, and what Adcoin is a cryptocurrency that you'll be creating together with Adlan in module 2 of this course. It's a short preview of the exciting stuff that's coming up ahead. And something I wanted to point out here is that notice how I put not just one transaction into this block, but several. We'll discuss this in more detail in module 2, but it's already a good idea to keep in mind that a block doesn't just store one single transaction. A block stores multiple transactions, so several transactions get put into a block, and then the blockchain moves on to the next one. So just something to keep in mind, and we'll discuss this in more detail later. Then also in the block we've got a field for the previous hash, or the hash of the previous block, and this is a very important feature of blockchains because that's how the cryptographic link is facilitated between them. Without this field, the blockchain wouldn't be a blockchain. And finally, we've got a field for the hash of the current block. And how do we get the hash of the current block? Well, we take the block number, the data, and the previous hash. We put all of that together into a hashing algorithm, and it spits out a hash for us. And there it is. That's our hash. And so here, this instantly asks for a question. And the question is, if it's so simple to just take the block number, the data, and the previous hash, put into a hashing algorithm, and get a hash out, which takes like half a second. If it's so simple, then how come, what's the whole fuss about mining? How come there's so many, hundreds of thousands mining rigs around the world, or nodes around the world, and lots of mining rigs and a lot of computational power is dedicated to them? Why is this all happening, and what's this competition that everybody's in if this is all there is to mining a block? Well, in reality, it's not as simple as that. There's actually another field in a block, and it's time to reveal this field. The field is called nonce, and nonce stands for number used only once. And so this field is what mining is all about. As we'll see from this tutorial on the next one, everybody is just changing this field all the time. So to understand this, let's have a look at what is it that now controls the hash? What is it that now dictates the hash of the block in this new updated structure that we see? Well, it's these things highlighted in the green square. We've got the block number, the nonce is now included in that party, and then we've got the data and the previous hash. So now we take all these four components, so we put them into a hashing algorithm, and then it will spit out the hash value. And so all of a sudden, now what the nonce gives us, it gives us extra control, gives us extra flexibility. Now we can manipulate the hash value by changing the nonce. So we don't have to change the block number. We can't change the block number because the block number is the block number. We can't change the previous hash because it's linked directly to what we have in the previous block. And we can't change the data because that would mean we're tampering with the data, and that would defeat the purpose of a blockchain. It has to be an immutable ledger. We want to prevent tampering. So now, because we have the nonce,
Yeah, I think I. Is this working now? Is this working now? This is working, but the volume is weird. 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 Hello? 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 Hello, I am saying this long sentence just to saying this long sentence just to saying this long sentence just to check if things are working. 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 Hello? Hello? Are things working fine here? 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 I have reduced the OBS volume. I have reduced the OBS volume. Increasing the OBS volume. Increasing the OBS volume. Increasing the OBS volume a little more. Increasing the OBS volume a little more. Increasing the OBS volume a little more. Let me increase it 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 a little more. I guess it is fine. 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 How are things looking right now? How are things looking right now? Yeah, the noise suppression is definitely off. The noise suppression is definitely off. Noise suppression is definitely off. How do I sound now? How do I sound now? Do I sound better? Do I sound better? I definitely think I sound better than before. I definitely think I sound better than before. How do I sound now? How do I sound now? I would definitely have to turn off my fan and then it would solve everything. My fan and then it would solve everything. Yep. Yep. So I have removed the biggest noise creator in the room. Biggest noise creator in the room. Biggest noise creator in the room. And now you can hear the birds. 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 Getting back to this, let me turn this off.
We are free to change the value of the nonce, and the nonce is just basically a number. We're free to change the value of the nonce, and that will allow us to change or to manipulate the hash, to vary the hash. The proper word is vary because, as we know, the hashing algorithm, we cannot predict in advance what it will spit out. We put in a nonce and it will spit out something, so we cannot control the hash, but at least we can vary the hash by varying the nonce. So let's have a look at how that works. So let's put in 19. So here, let's go back for a second. So nonce is like 0 right now. It's empty, and that's why we have a certain hash. Then we put in like a random number, 19. We get a hash, a different hash. 20, different hash. 21, again, different hash. 22, 23. Then we can do like, oh, something I wanted to point out here. So you can see that the hash is changing, and also notice how when we go from, let's say, 20 from 21 to 22, notice how the hash is changing absolutely like dramatically. And why is that happening? Well, that's the avalanche effect in action. What's happening is in the block itself, essentially we're just changing one bit of information. So if you write it out in binary code, you'll see that this block has like some combination of ones and zeros, and to go from this to this, we're just changing literally one bit somewhere from a 0 to a 1. And that is that's all with the chain we're doing, but at the same time the hash, it's completely unrecognizable. It's completely different to what we had before, and that is important. That will be important, why we'll see in the next tutorial, but that's the avalanche effect in action. I just wanted to illustrate that. Okay, so that's how we change the nonce. So let's take a random number. There's 243, like there's 10,955. So nonce is a number that can go up to like 4 billion something. So it's quite a large number. There's a lot of variety that you can play around with the nonce, and that gives you variability in the hash. So there we go. That's a start to mining. We'll end the first tutorial of this two-part series here, because that was like an important concept, that mining the blocks have nonce, which we can control, we can change to vary the hash. And in the next tutorial we'll put it all together and you'll see why exactly that's important and what the miners are actually doing with their electricity and with all their hashing power. Alright, so I hope you enjoyed today's tutorial, and I look forward to seeing you next time. Until then, enjoy blockchains. Alright, part 2, how mining works. Let's have a look. So we left off last time over here, where we have this block, and we now know that we can control, or we can vary the hash of the block by varying Alright, part 2, how mining works. Let's have a look. So we left off last time over here, where we have this block, and we now know that we can control, or we can vary the hash of the block by varying the nonce, the number, the extra field that we identified. Okay, so how does this tie in with mining? Well, let's have a look. The first thing that we're going to need to do is to make a statement. And the statement is that a hash is a number. And if you already know this, then bear with me, this will just take like a minute. If you don't, then this will be very useful for us going forward. So here is an example of a hash. This is a proper SHA-256 hash. It takes up 64 bits, 64 digits. There's 64 digits here, 256 bits. And the statement is that this is actually a number. It's not just a word, it's not just a combination of characters, it's not just a label, it's an actual number. So you can increment it, you can do mathematical operations with it. And why is that? Well, a hash is actually a hexadecimal number. So here you can see digits, so from 0 to 9, and also you can see some letters. But the letters are limited to F, so it's A, B, C, D, E, F. And what a hexadecimal number is it's like a decimal number, but instead of just having digits from 0 to 9, it also has those 6 extra ones. So A stands for 10, B stands for 11, C stands for 12, D stands for 13, E stands for 14, F stands for 15. And so that's all there is to it. And we can actually convert this hexadecimal number into a normal decimal number, and it'll look like this. So there's our decimal representation of our hexadecimal number. As you can see, the number is visually longer, and that's because in the decimal system we only have 9 digits, whereas in the hexadecimal system we have, in the decimal system we have 10 digits. Funny. But in the hexadecimal system we have 16 digits. So therefore, every digit can encode a higher value, if you want to call it that. Every digit will encode a higher value in the hexadecimal system, and therefore visually the number is shorter. But in essence, the overall value of the number is actually exactly the same. It's just represented in a different system. It's like we can take a decimal number and convert it to a binary, into ones and zeros. It'll be very long, but it'll still be the same number, just represented in a different system. Same thing with hexadecimal. We can take the same decimal number, convert it to hexadecimal. We can convert it to any system we like. We can convert it into a system with the base of 57 if we wish. But just that those are the commonly used ones. The decimal one, which we use in the real world, binary, which computers use, hexadecimal is also used for some things. One of them is hash numbers. Then here's another example. There's another hash number, also of course hexadecimal. This is another SHA-256 hash. As you can see at the start, there's leading zeros. You don't have to write them out, but I included them here just to illustrate that the visual length of this number is the same as the previous one. It is also 64 characters or digits in length. And if we convert this to a decimal number, there we go. There's the decimal version as well. Don't have to write out the leading zeros, just a smaller number. And here's another hash. It's also, this one's even smaller because it has so many more leading zeros, and this is its representation in decimal. Okay, so we've identified that hash is a number. What does that give us now? Why is that valuable? Well, now we can actually illustrate this. We can draw hashes because we know that they're numbers, so we know they're consecutive order. Some are smaller, some are bigger. So let's draw a pool of hashes. We'll call this pool the pool of all possible hashes.
Since hash is a number, hash is a number. Hash is a number. Some so hashes have order. One hash would be bigger or smaller than other hash.
At the bottom we have the smallest ones, but at the top we have the largest ones. And basically what this is all possible variations of this hash value. So starting from the smallest at 0, and then going all the way up like that. So it doesn't matter like how exactly we structure it, but like let's say it goes like a snake all the way up. It increases until it gets to the very top where what will the highest one be? Well, that's when all of these digits are F all the way. So that's the highest. And so we're just gonna order them like that, and this is gonna be like a map for us. And so now we're going to see where these hashes fall on the map. So we know that, well, let's say this top one falls somewhere over there. This one is smaller, so it has to fall lower. This one's smaller, it falls lower. And so there we go. Those are our hashes. They're illustrated on the map. We can get rid of the decimal representations now. And this leads us up. This is a very nice setup. This is in combination with the previous tutorial. Very nice setup for what is mining all about. Like what's this whole fuss about mining? How does it work? And sort of how does it work? And we'll get to the fuss after that. So how mining works is, in essence, the blockchain system or the blockchain algorithm will set a target. So there's a target that's set for miners to accomplish a certain hash. So let's say the target's over here. Target, there we go, that's our target. And the way it works is any hash higher than the target doesn't count. So if you find a hash for your block that is above the target, that doesn't count. That's not good enough for the blockchain. It has to, in order to be included in the blockchain, it has to be below the target. And the important thing to know is this is completely arbitrary. There's no economical reason for it. There is no like logical or computational, mathematical, cryptographical reason for it. It's just a way to put hurdles in the way of miners, to create a challenge for them to solve. That's the only reason there is this target. No other reason. And so in this case, if a miner found this hash, it wouldn't count. It would be not good enough. They would not be allowed to create a block with this hash number. This hash is also not good enough. It's above the target. But if you found this hash, you'd be welcome to create a block. You'll be allowed to create a block, and that's when you would be considered the miner who actually mined the block because you found a hash like that. And this is like just a high level. We will go into detail like in a second in this. But before we do, I wanted to give you guys a small tip that
Finding the hash. What do you mean by finding the hash? Finding the hash. So hash is created with the SHA-256 encrypting protocol, but then we end up with a hash. But we hash something. What do we hash? Do we hash the block over here? So we are hashing the block, and only variable is the nonce. So we would be changing the nonce to achieve a hash that is below a target number. That is what
a good
I'm
way
guessing.
of thinking about the target is actually in terms of leading zeros. So as you can see, the lower you are, the smaller number, and the more leading zeros there'll be. So if you think of the target rather than as like trying to remember what the target is in terms of hashing, just remember the number of leading zeros. For instance, 4 leading zeros. So let's talk about that. And actually, in the practical tutorials, Adnan will be showing you how to code a blockchain, and you will be using these 4 leading zeros. You'll see that in the practical side of things. So that's how we're going to think about the target. And now let's discuss what we just talked about, the whole mining concept. I know it's right now it's very vague, very unclear. So let's make it clear. Let's make it super clear. So after this tutorial, you walk away and you're 100% sure what mining is all about. So let's go back to what we discussed in the previous tutorial. So here we've got the block, and we know that what we have inside this block is the block number, the nonce, the data, the previous hash. And most of the fields here are, you cannot touch them. You cannot tamper with them. You cannot change the block number because it's a block number. So we're trying to add, forget about this part. It's just, we only have the chain on the left. There's no more chain on the right? So this doesn't exist. So we want to add a new block. So we know that block number, we're going to be adding block number 3. Okay, so you can't change that. The data in the block. So as we discussed, we don't want to change the data. We cannot change the data. In reality, there's a bit more to it. Like in module 2 of this course, we'll understand how we can change or vary the transactions.
Yeah, mic is back. Learning with time.
that go into the block. But for now, for us to understand how mining works, it's good enough to agree that we have this set of transactions that needs to go into the block, and we cannot change it because if we agree that the list of transactions is set, then we cannot change any details of each transaction because we don't want to tamper with the data, and that's the whole concept, whole point of
What
blockchain.
is going
That
on?
it's an immutable ledger. Then we cannot also change the hash of the previous block. We can change. Cannot change this value because it has to be cryptographically linked to the hash of the previous block. So the only thing that we can actually change in this whole block is the nonce, and the nonce allows us to vary the hash of the current block. So let's see what.
Okay, I need to leave, so I would leave it here. We'll fix all the technical issues and come back.